Hey everyone, we are taking a look at the structures of the heart. Specifically, we're going to look inside of the heart. What allows the heart to pump forcefully, not stick to itself, and keep things moving efficiently so that you get blood around your whole body. All right, first let's orient ourselves. We are looking at the anterior side of the heart. We can see the anterior interventricular sulcus. We can see the pulmonary trunk going to the pulmonary arteries. We can see the aorta curving up and to the left. This is the left side of the heart. This is the right side of the heart. Here's the right atrium. You can see the auricle of the right atrium. Here's the auricle of the left atrium. It's kind of just, it's better seen from the back, from the posterior side. Here's the right ventricle. Here's the left ventricle. Let's take this off and get a better look. All right, from the right atrium, we pump blood to the right ventricle. Within the right atrium, we can see a type of muscle. It has a texture to it. It's called pectinate muscle. Remember we went over the pectoral muscles? The pectoral muscles had this comb-like appearance, and so this does too. Pectinate muscles are comb-like. What's the advantage of having a comb-like appearance? The auricles of the atria are meant to expand. We want to have as much blood being returned to the heart as possible. By having pectinate muscles, by having this texture, it's kind of like an accordion. It allows the heart to expand even more. It's kind of like the rugae of the stomach. So pectinate muscles allow for expansion as well as pushing blood into the ventricles. We get to the right ventricle through this valve. This is called you can call it the right atrioventricular valve, but you can also call it the tricuspid. It has three cusps. 1, 2, 3. Let's see if we can get a better look this way. It has three cusps. 1, 2, 3. Tricuspid. The tricuspid valve makes sure, any valve makes sure that blood flows in one direction, but not the other direction. We want blood to flow from the right atrium to the right ventricle. The valve, we don't want it to invert. We want it to open up this way, but not the other way. These ensure of that. These are chordae tendineae. Chordae tendineae. They prevent this valve from inverting, as well as this one we'll get to in a minute. The chordae tendineae, to help reinforce the chordae tendineae, we have it attached to this muscle found in the right ventricle. These are bumpy-looking muscles. These are called papillary muscles. We've seen that word before. Papilla means bump, or papilla means bump. So papillary muscles are ones that protrude out, attached to the chordae tendineae. The right ventricle is lined with lots of textured muscle as well. They look very meaty. They're very strong. There's a lot of muscle there. They're called trabeculae carneae. They're branched. You can see how branched they are. And trabeculae carneae just means meaty branches. Yeah, it's a funny name. So the trabeculae carneae, what's the advantage of that texture? Besides having a lot of muscle to allow for contraction, by having the texture, it prevents the valves from, prevents the ventricles from sticking to each other. If you have a suction cup, and the suction cups are smooth, so when they stick, when you squeeze them together, it's hard to pull apart. You don't want the right ventricle to stick like this. You want it to keep squeezing, relax, squeeze, relax. By having this textured muscle in the ventricle, it allows for that. Trabeculae carneae are the textured muscles of the right ventricle. From the right ventricle, you can see here's the right ventricle. From the right ventricle, we squeeze blood out of the heart into the pulmonary trunk. This valve is the pulmonary semilunar valve. Pulmonary semilunar valve. So from the right ventricle, we pump blood out of the heart into the pulmonary trunk through the pulmonary semilunar valve. Blood will go through the pulmonary circulation. Blood will then return to the heart can see these two are from the posterior side, these two in red, these two in red. These are pulmonary veins. These pulmonary veins are colored red because they're returning oxygenated blood to the heart. We sent blood to the lungs so that we can oxygenate it, and now we're returning it back to the heart so that we can give it more force to be sent throughout the whole body. So we're now in the left atrium. From the pulmonary, you can see these holes here, from the pulmonary veins to the left atrium. You can see the left atrium has an auricle as well. In that auricle, you've got pectinate muscle so that it can expand. From the left atrium, we pump blood to the left ventricle. The left ventricle also has trabeculae carneae. From the left atrium to the left ventricle, you've got another valve. This is a bicuspid or mitral valve. This has 3 cusps. We have 2 cusps over here. Tri on the right, tri before you bi. Bicuspid is on the left side. Through the bicuspid valve, which does have trabeculae carneae, which does have chordae tendineae attached to papillary muscles to prevent inversion, and trabeculae carneae in the left ventricle to prevent suction. So right and left ventricles are very, very similar. Both have trabeculae carneae, chordae tendineae attached to papillary muscles. The left ventricle is thicker walled, like all of this is left ventricle. Right ventricle is thinner because you don't need as much force to pump blood to the lungs. The lungs are next door to the heart. One thing that the right ventricle has that the left one doesn't is a band right here. It's called a moderator band. It's labeled here as 60. There's a band to reinforce the right ventricle. It's called the moderator band. You don't need to reinforce one of the left ventricle because it's so thick. You need a moderator band here to prevent overexpansion. Make sure that it stays intact. So there's this band down here called the moderator band. All right, from the left ventricle, we pump blood out of the heart to the aorta. This is the aortic semilunar valve. Aortic semilunar valve. And we pump blood out of the heart. Blood then returns to the heart through the superior vena cava, that's right here, and the inferior vena cava, that's right here. Superior vena cava, inferior vena cava. From the upper body, from the lower body. The vena cava return blood back to the heart, to the right atrium, and we complete the circle again. One more thing I want to show with this. In the right atrium, you've got this oval depression. It's called the fossa ovalis. That's literally oval depression. Fossa ovalis. When we were fetuses, this used to be a hole called the foramen ovale, different from the foramen ovale that you have in your skull. I mean, both are called foramen ovale. This foramen ovale, it was to bypass pulmonary circulation. You don't use your lungs when you're a fetus. You're surrounded by water, not by air. So this foramen ovale was one way to bypass that, much like the ductus arteriosum, which is now the ligamentum arteriosus. Ductus arteriosus, which is now the ligamentum arteriosum. So this depression in adults is the fossa ovalis. Let's take a look at another model. This one here. Anterior interventricular sulcus, so right ventricle, right atrium, left atrium. Here's a pulmonary trunk. I'm going to remove it. Here is the aorta curving up to the left. I'm going to remove that. As well as the superior vena cava right here. Okay. Right atrium has pectinate muscle. Right atrium through the bicuspid valve attached with chordae tendineae to papillary muscles. You can see that a little better here. In the right ventricle, we've got trabeculae carneae. We have a moderator band. From the right ventricle, we pump out This is the pulmonary semilunar valve. Pulmonary semilunar valve to the lungs. Then from the lungs, we return oxygenated blood to the left atrium. We have our pulmonary veins. Pulmonary veins from the right side, from the left side. Here's the left atrium, which also has pectinate muscles in the auricle part. Left atrium. To the left ventricle, you can see the tricuspid valve here. Tricuspid valve attached with chordae tendineae to papillary muscle and has trabeculae carneae. There's no need for a moderator band. No moderator band on the left. You can see how much thicker the left is. From the left ventricle out, the aortic semilunar valve. Here's that aortic semilunar valve, and we go out to the rest of the body. Then blood returns to the heart through the inferior and superior vena cava. It was shown right here. Superior vena cava, inferior vena cava. One more model, just for good measure. We're looking at the anterior side of the heart. Here's that anterior interventricular sulcus. Here's the left atrium, the auricle of it, right atrium. Here's the auricle, right ventricle, left ventricle. Pulmonary trunk to the pulmonary arteries. Here's that ligamentum arteriosum, aorta, superior vena cava, inferior vena cava on the back, pulmonary veins on either side. Remove the front so you can see more. And I'll remove the top too. We go from the right atrium, pump blood from the right atrium through to the right ventricle. This is the tricuspid valve. Tricuspid valve has chordae tendineae attached to papillary muscles. This does not show the moderator band very clearly, but I guess it would be on this side. So this is on the right side, this moderator band. From the right ventricle, we go through to the pulmonary trunk. So here is our pulmonary semilunar valve. From the pulmonary circulation, we return with oxygenated blood through the right pulmonary veins and the left pulmonary veins into the left atrium. Here's the left atrium. So we return blood to the left atrium. Now from the left atrium, which has pectinate muscle, through into the left ventricle through the bicuspid valve or mitral valve. Bicuspid or mitral. Left atrium to left ventricle. Left ventricle has chordae tendineae, or we've got on this valve we've got chordae tendineae to papillary muscles. We've got trabeculae carneae. It's very, very thick. Pump blood to the rest of the body, out of the heart, out of the heart to the aorta, and over here you'll have your aortic semilunar valve. So your aortic semilunar valve would be hiding in here somewhere. To the aorta, to the rest of the body. All right, I hope that helps. 3 different models of the heart showing the different muscles and structures that help ensure that blood flows in one direction and forcefully to both the pulmonary circulation and systemic circulation. Let me know if you have questions. Thanks for listening.